Okay, I think the last video left off right here. So I was going to show you that some of the older model calculators don't have the feature where you can go in and type this directly, which is called log base 2 of 8. If I hit the log button now, it's just going to show log, and it doesn't give me the opportunity to write that number. This is called base 2, and it's a little bit lower than the 8. So what I have to do is actually split it up. So like this 8 is going to be, so it's going to be log 8 divided by log 2. That's the only way to type it into the older calculators. So let me just do that, divided by log 2. And I hit enter, and then the answer is 3. And that's because a logarithm is saying what number from the base of 2 is going to equal 8. That's what a logarithm means. Okay, so I think I'm just going to move forward a little bit if we have time, because the recordings only let me do 15 minutes at a time. So if I can fit it in 15 minutes, we'll come back to this. But I think this is a really hard concept to answer these parts until we do number 70 on the classwork. So you can either turn it over or start number 70 right below what you've already written down. And if you need to pause the video, go ahead and write down these questions. They're taken directly from the book. Okay, so all of them, well, most of them, it's giving you the logarithm and then you have to say what it equals. But there are a couple of them down here where I could put a variable, but the book put a question mark. So we're going to have to fill it in kind of in the opposite way, where they give us the outside answer, but you have to fill in the inside. All right, so the way that I want you to think of this is, since we're trying to figure out what the logarithm, it's called log base 2 of 32. Since we're trying to figure out what that equals, you could put, if you want, like a variable here. And so what you're really doing is you're going to unwind the logarithm. So you're going to go to the base to the outside number. So I like to go counterclockwise if the logarithm is on the left side. And then you're going to set it equal to 32. So it's going to go 2 to the x power and then equals the 32. Now we just have to figure out, like, 2 to the what power is 32. We did that on the other page. It was on one of our, what was in the chart. So I think we already did that. It was like 2 to the y equals 32, and we figured out that it was a 5. So 2 to the 5th power. So therefore, this answer is 5. So if I were to go in my calculator, and I would go log, the way I have to type it in, this is kind of like the older way of doing it. I'd have to go log 32 divided by log of 2. And I would get 5. If you have the newer model, which I don't have one of those at home, but you would go to math, and I believe if you just scroll down, there's like a part for you to type in the log with the base, but the older ones don't have it. So let's do the next one. Log base 2 of 1/2. So again, what we're trying to do is go 2, because that's the base, to the what power. So we're going to go x because there's nothing out here. And then equals 1/2. So I think that is another one that we did on the first video. So really, the fact that this 2 became a fraction, 1/2, just means that this was a negative exponent. So the x would have had to be a -1. So 2 to the -1 is going to equal 1/2. Now all of these you can do manually. Like, I'm not wanting you to use your calculator. So like if we had a quiz or something, you wouldn't be able to use your calculator. But I'm just doing it now to show you. We're going to do a little check. So log, I'm doing the 1/2 first and then divided by log 2. Okay, so we got -1. And I didn't really show a lot of work on this because we also did that one on the other page right here. So it's 2 to the -1 is going to equal the 1/2 because 2 to the -1 is the same thing as 1 over 2 to the +1. All right, so I'm just going to circle that one. And then this one is saying 2, log base 2 of 4. What does that equal? Well, it's saying 2 to the what number, because there's nothing out here. So 2 to the what number is going to equal 4. And we could do that in our head because 2 squared equals 4, which means this is equal to 2. Okay, the next one. 2 to the what power equals 0. So I'm going to rewrite that. 2 to the what power equals 0. I think we did talk about this also on the other page, that no matter what number you put in for x, you will not be able to come out with a value that's going to equal 0. We can find something that's going to approach 0 or get really, really close to it, but it's never going to touch 0. So we're going to have to call that one, it's not possible, so we'll just do like undefined. And I could just do that in the calculator to show you. So if I did log of 0 divided by log of 2, it's error, go to. All right, next one is log base 2 of question mark this time equals 3. So you're just doing it, like I said, in counterclockwise order. So whatever you have, so you start with the base number, so 2 to the 3rd power equals question mark. But normally we would put a variable in place of that. So you're pretty much done. You just evaluate what's 2 to the 3rd power. So that's 2 times 2 times 2. So we're going to say equals 8. So the missing value in this one was 8. Okay, the next one, same idea. So we're going to do 2 to the 1/2 power and set it equal to our variable or the question mark. 2 to the 1/2 is going to equal whatever we're looking for. Well, 2 to the 1/2, really it's the same thing because that's a fractional exponent, so it's the same thing as saying the square root of 2. And you could either leave your answer like square root of 2, or we could do the decimal, but I'm just going to leave it like that. Okay, same thing here. 2. This time we don't know the outside number, so 2, I'll just call it to the x equals 1 over 16. So what we want to do, excuse me, on that one is convert the 16 to a base of 2 so that these kind of line up with each other. So if I have 2 to the x power, and I'm going to set it equal to, instead of 1 over 16, I'm going to think of it as 1 over 2. So to the 4th power is 16. So what that means is for this fraction, or for this exponent to turn to the fraction, the x must have been negative. So we're just going to have to use our answer. It was -4. So x is going to equal -4. And I'll just plug that in the calculator just to verify it. So log of 1/16 divided by log of base 2. And we got -4. Again, this is just kind of like easing into logarithms. It's not very intuitive at first. I'll probably come up with some more notes. This is kind of jumping into the classwork. Okay, so then this one is 2. We're going to go 2 to the 0, and then equals the question mark. But like we said before, anything to the 0 power is 1, so our answer is just going to equal 1. Okay, so we'll do a couple more practice ones, and then we'll be done with the video. Number 71, I cut it short a little bit. It just says, a logarithm represents the function that is, and I'll just fill in the word that we're looking for, that's an inverse. So something we're going to learn about is that the logarithm and an exponential function, they are basically just like opposites of each other, or inverse. So they're kind of like the opposite rewind order of each other. All right, so just a couple more A through E on number 72. See if you can try these on your own. So you're going to say, okay, 7 to the what power is going to equal 49? What does log base 7 of 49 equal? You are not supposed to do these in your calculator. I was only showing you so we could check it. Okay, so 7 to the what power, I'll just call it x, is going to equal 49. So hopefully you figured out that that would be 2, because 7 squared is 49. Next one, 3 to the what power is going to equal 81. This one would be like if you did 3 squared, that's 9. So 3 to the 4th power, because that would be 9 times 9, is actually 81. Again, everything could be verified on the calculator, but not dependent upon. All right, so the answer to that one is 4, because 3 to the 4th power. So hopefully you're starting to just kind of get the idea. So this one is 5 to the what power, and it's a little odd, but this is taking place of like where the 81 is on that problem. So we've got 5 to the what power is equal to 5 to the 7th power. Well, you could multiply this out, 5 to the 7th, but that would just be a very large number, and it would just be an extra step that you don't need to do, because if we're trying to make these two equations equal to each other, all we have to do is put a 7 in for the x, and then they will look identical. So it just means that the variable x, it was a 7. So 5 to the 7th power is going to equal 5 to the 7th power. Kind of the same idea here. And we are going to learn about a property too of logarithms that kind of helps us with a shortcut. But for now, I'm going to go 10 to the whatever it is out here, so I'll call it x, and then set that equal to this part, which is 10 to the 1.2. So really, it's the same idea as this one right above. So x is going to equal 1.2. Because if I replace x with 1.2, that would make these two congruent statements. Okay, the last one is 2 to the, we'll just call it x like we've been doing, and then equals 2 to the w plus 3. So in other words, it's just like the other ones we did, but a little more complicated because it has the it has a variable w in there. But we're just basically saying that whatever this is, it's going to equal the same value as whatever that one is, because they both have a base of 2. So I'm going to call that w plus 3. Okay, good. I think we finished the notes, but I'm going to see if I have a little time to do my flippity, let's see, my random name picker for the extra credit. So Bobby, I'm going to write you down. I'm not sure if I forgot where my list went. Okay, so I have Bobby in 3rd period. If for some reason I already picked you, because I did write these down. Oh yeah, actually I did call you. So this name picker likes you. So I'm going to do one more. Ryan. Okay, Ryan, I'm going to write your name down for 3rd. And then in 5th period. Okay, Sean, I called you, and it seems to pick the same people. All right. So I know I did Sean Kennedy before, so I'm going to do a different drawing. Adrian, I don't think I've called you yet. So we're going to go Adrian for 5th period. And last one, 7th period. Oh wait, 7th period, they don't do this lesson. Sorry. All right. Thanks everybody. Take care of yourselves. Hope you're doing well. Bye.